Hello everyone, welcome to IS 300 and today's discussion of Security Guidance Domain 6, Management Plane and Business Continuity. In today's discussion, we'll go through an introduction, then we'll have an overview and some recommendations. Cloud-based systems, just like any other system, requires administration and management. To accomplish this administration and management, we use something that is referred to as a management plane. The management plane gives you the ability to configure, monitor, and manage a cloud-based system. It is simply an interface for managing assets. It is a web-based interface, and it makes the configuration and monitoring and management available and accessible through the internet with a single set of authentication credentials. The convenience of using this as an internet-based tool also introduces security risks, which we will talk about in this chapter. The management plane uses application programming interfaces, or APIs, to call web consoles through the management plane instead of using boxes and wires like we did back in the day. Centralization, of course, is a benefit, a single point of failure also, and an inherent risk because it is centralized. If you get a hold of the management plane, basically you have control of the entire cloud system. The management plane is responsible for the management of assets. The provider is responsible for making sure that the management plane itself is secure. The user then is responsible for how the assets are configured in the management plane, and the user, the cloud user, is responsible for properly configuring their management plane. Business continuity and disaster recovery in the cloud, usually by its very nature, requires involvement of a third-party vendor or a third-party provider, usually the cloud provider. The three aspects of business continuity and disaster recovery means ensuring that continuity and recovery can happen if there is a man-made or natural disaster, and managing outages. Those outages could be from a flood, from a fire, from an earthquake, from any number of different types of events, catastrophic events usually. And also you have to consider options for portability, for being able to move to a new location if the old location is unusable. Cloud providers usually offer options to improve the resiliency beyond that is available and attainable in traditional infrastructures. That's one of the benefits of moving to the cloud. You can configure something called a zone. Multiple zones can then be enabled with virtual machines, and that way you don't have a single point of failure. You have load balancing capabilities. You have the ability to move applications to a different zone. So if one zone goes down, the other zone is still up. The application can continue to run. The concept of lift and shift, if you are migrating to the cloud, simply lifting an application from the old traditional environment and shifting it to a new environment requires architectural changes. If you don't change the architecture and the nature of the application, it will almost be guaranteed to reduce the resiliency of the application. Virtualization and migration without changes, of course, increases the odds of failure. So a risk-based approach is key. Not all the assets in the cloud need equal continuity. Over planning is going to detract from the critical components that must be up and running. So don't overplan. Look at historical performance, and there's some metrics that you can use. They are defined here: the recovery time objective and the recovery point objective. Those are very similar to what we did in the traditional infrastructure, lost man hours and lost workstation hours and things of like that nature. You can calculate the cost associated with downtime, and recovery time objective is simply another way of assigning a value, the amount of time, how long it takes for the business to get the service back up and running, and how much the amount of time in which data loss can be tolerated. Usually in critical environments, that number is 0. The management plane controls something called metastructure. Metastructure is protocols and mechanisms that provide the interface between the infrastructure layer and all of the other layers in the cloud. The metastructure is the glue that ties technologies together and enables management and configuration. Cloud computing itself is taking physical assets, networks, processors, and using them to build resource pools. Those resource pools then can be provisioned using the metastructure. The management plane includes all of the interfaces for the users to manage their own resources in the cloud. Application Programming Interfaces, APIs, is an ingenious way to allow for the programmatic management of the cloud. Many providers will provide software development kits and command line interfaces to make integrating APIs easier. The web consoles are managed by the provider. You can use domain name server redirection and federated identity to manage the assets in the cloud. APIs are typically REST capable, and REST is fairly easy to implement across the internet. I have included in this week's material a REST tutorial if you are interested and curious about what an API looks like. I would encourage you to take a look at that tutorial. It is based on XML. REST APIs have become the standard for web-based services, and they run over HTTP/S, of course the S for secure, and work very well in diverse environments, primarily because they're web-based. REST itself, representational state transfer, a set of rules that the developer follows when they create an application programming interface. It allows programs to communicate with each other. The developer creates the API on the server and allows the client to talk to it. So it's a client-server interface that is used for purposes of configuring and managing the management plane for a cloud. And again, I encourage you to take a look at the tutorial in this week's reading material. The management plane defines how and what you can do within your cloud platform or with your cloud provider. Identity and access management includes, of course, identification, authentication, and authorization. This specifies who has access, what type of access, and what kind of authorization is required to gain access. There should always be a super administrator with administrative privileges that controls pretty much everything, the entire configuration. This should be an account that is enterprise owned. It shouldn't be a personal account. It should be locked down, of course, for obvious reasons. And it should not ever be used unless there is some sort of a major catastrophic failure. Separate from the account owner, you can create super admin accounts for individual administrators. And of course, these are going to be in a very exclusive group of administrators who you call when the system has crashed, when there's a natural disaster, or something along those lines. These are used in extreme circumstances only, and all of these accounts will have multi-factor authentication, either a password and a PIN, or biometrics like fingerprint or retina scans, things of that nature. The cloud consumer should only configure those parts of the management plane that have been specified by the provider. The provider is responsible for everything, and to secure a management plane, it typically will require these 5 major facets: perimeter security, customer authentication, internal authentication, credential passing, authorization and entitlements, specifying permissions and things of that nature. And then, of course, logging, monitoring, and generating alerts. Alerts can go a long way towards warning that disaster is pending, and in some cases can be used to ward off a catastrophic failure. Business continuity and disaster recovery is a shared responsibility between the provider and the consumer. It is best to use a risk-based approach. So you find out how much downtime the consumer rather, can tolerate, and the capabilities should vary between providers. So when determining whether you're going to select a vendor, look at their record, their history, and understand the risk associated with selecting a particular vendor. Because business continuity and disaster recovery should account for the entire cloud, the whole logical stack, including the metastructure, the configuration, and things of that nature that need to be backed up. Of course, backups are critical in a business continuity and disaster recovery plan. The software-defined infrastructure allows you to create a template to configure some or all aspects of a cloud deployment, which can then be used for rapid rebuild and redeployment if necessary in a new location. Infrastructure, adjust your architecture. Make sure that applications that are moved to the cloud have been redesigned so that the lifting and shifting is minimal, but rather you redesign and then you migrate. The infrastructure, which is the data, the information itself. Make sure that the data is synchronized and replicated and accessible. If one location goes down, the data should be available either by backup or in a distributed environment at a different location. The applet structure, the code, the messaging queues, everything in an application is part of the applet structure. You should design applications for graceful failure in case of an outage. Downtime is something that should be considered as an option. If you are a critical shop that needs 24/7, 365 operation, then you better have the redundancy in place so that if there is downtime, if there's a hardware failure or a data center failure, that you can continue to function seamlessly in a different location with redundant hardware and software. Plan for emergency downtime notifications, alerts, responses, and things of that nature. And then there's something called chaos engineering, which allows for testing, continuous testing to occur to make sure that in the event of a failure, the business continuity can continue, the business can continue to function because the chaos engineering has verified that your strategies for recovery are in place and they are effective. It's possible to lose an entire system, the entire cloud, or one specific location can go down. Accepting the risk of that happening is a legitimate option. Graceful failure can happen if you have the appropriate API calls in place. And if you don't have a separate backup storage provider, the backup storage provider and the infrastructure provider are the same, then the likelihood of your successful backups being accessible when you need them goes down considerably. Always better to have separate backup provider from the infrastructure provider. You should have an alternate application in place if you need to migrate. So you have a spare application, if you will, that can handle the load in case the primary application goes down. If the data is not usable, then your recovery strategy is pretty much useless. Business continuity and disaster recovery should include everything down to the physical facilities. Response time objectives and recovery time objectives and recovery point objectives must be stringent. If the cloud goes down, everything is down. And of course, if you're 24/7, 365, you cannot afford downtime, then the money has to be spent up front for extreme redundancy of location, of hardware, and software. Contractual requirements might also come into effect if there is a disaster. What is in the contract? And how do you plan to fail over to a different geographic location in a different legal jurisdiction? That might introduce some contract violations for local laws and things like that. So if it's a company that is geographically dispersed, it is a good idea to know what the laws of the new location, how they will impact your systems and your operations. So here are the recommendations. Ensure that there is always strong perimeter security, physical security, cameras, security guards, locked premises and things of that nature are very important. Surveillance is critical. Strong authentication, multi-factor authentication, biometrics, fingerprints, PIN numbers, passwords, and things of that nature. Usually it's going to be something you have and something you know. Multi-factor authentication, something you have and something you know. Multiple accounts. Of course, that's risky if those accounts are breached, but if you have multiple accounts and you have strong authentication in place, then that reduces the risk. Separate super administrator accounts from the day-to-day administrator accounts. That's something that can trip up an organization if they are using the same account for administration and that account has access to everything. That account is breached, then the whole system is now breached. Consistently, implement least privilege accounts. The least privilege that you can tolerate is the privilege that they should be given. Don't give more privilege than is needed, is what they're saying here, and make sure that multi-factor authentication is used whenever possible. For purposes of business continuity, plan, architect for a failure. Use a risk-based approach for everything. Assume that a catastrophic failure is going to happen, because it is. It can be natural or man-made. We know that natural disasters are happening with more frequency. We also see that man-made disasters, fires and things of that nature, are also seeming to happen more frequently. Designing for high availability is critical. Cross-location should always be considered. You almost have to consider cross-locations in order to have the appropriate redundancy in place. Images and asset IDs are working. Make sure they are working. Make sure your images are kept separate so that if you need to deploy virtual machines and you have the images available, you can be up and running fairly quickly even in the event of a disaster. Prepare for a graceful failure. In the case of an outage, if you have that luxury, in some cases a disaster, you don't have the luxury to prepare for graceful failure. But you can, again, have the redundancy in place, so even if it is a drastic and rapid failure, you can still, the business can still function. Plans for interoperability and portability, moving to a different location, using different cloud providers if necessary, or going to a completely different region with your own cloud provider, current provider. Those are options that are also available. Keeping the system up and running, no matter what, is what we are talking about here. This has been our discussion of Domain 6, Management Plane, and Business Continuity. Let me know if you have any questions.